So, we've learned basics of vectors and operations with the vectors. Today we're looking into the components of the vector. And first we need to introduce unit vector. Unit vector, let's say in vector A, and we put like hat on the top that denotes unit vector. What does it mean, unit vector? That its length of the unit vector equals just 1. So unit vector is a vector of the length 1. And if we dealing at this stage with the 2 dimensions, it's a length. Yes. All those, it's a length. And we have x and y coordinates, and we have vector OA, with the point A has coordinates, let's say 4, 2. We can introduce unit vectors along x direction. So unit vector along x direction we called I. Don't mix it with the I for complex numbers. I. And unit vector in the y direction we call J. So we can express vector OA. We can express as 4i plus 2j. So that is a component of the vector. We have its component in x direction, 4i times 2j. Times 2j. I put this dash. Yes?
Are we studying the vectors in the real field or the complex or Argand diagram, by the way? I don't know. Like vectors in the right, are we studying them in the real?
What do you mean real?
Like,
is this not real?
No, like in Cartesian. I don't know how to explain it. In Cartesian or Argand diagram? Okay,
What's the difference between Argand diagram and Cartesian plane?
complex numbers, I don't know.
What is complex number? In fact, it's just two-dimensional number. Complex numbers, two-dimensional numbers. So we can represent this as a vector, we can represent as a complex number. So you see, they like friends.
Right.
So now, if we have given some vector, let's say 5 vector A equals 5i plus 12j.
Starts at
what will be?
Ends at 512 from 0 to 512.
What are the lengths of this vector?
The length would be.
You should be able to tell it straight away.
12
Pythagorean
144 minus 25 is
13. Pythagorean triple. 5 squared plus 12 squared, square root is 13. So length of the vector A is 13. 5 squared plus 12 squared and take square root. Now let's find what will be the unit vector in the direction of A. To find the unit vector in the direction of A, so we put this hat to represent its unit vector. We take the vector A and we divide it by its length. In this way, we will get vector in the same direction, but the length will be 1. So that will be 5 on 13i plus 12 on 13j. This vector will have the same direction as vector A, but its length will be equal 1. So it's unit vector in the direction of the vector A. Yes?
So unit vector always equals 1.
That's why we say unit vector means length 1. We can have unit vector in the direction of x-axis has special name I, in the y direction j, but if we want to find the unit vector in the direction of any like random vector, we need to find length of this vector and divide vector by its length, and we will get vector of the length 1 and with the same direction as this.
What are you, so I don't know what's happened, what are you dividing?
I divide vector A
By the distance.
by its length.
By the modulus.
By its length. Vector divided by its length.
How do you know to do that?
So you're just teaching us.
Well, what will
You
be
know,
what?
you can't, you just, it's just like
We
a
just
rule.
got taught to.
Oh.
Yeah.
Oh, it's a rule, it's not
rule.
like we are meant to understand how that works.
No, but it does. What will be the if you did? What will be the length of this vector?
One.
1. We want to get vector the length 1, and this vector is parallel to this because we can get A will be equal if you multiply 13 by this unit vector. It's a parallel vector, so in the same direction. So you know everything to be able to understand that. Because it's a vector in the same direction, just 13. If this vector is length 13, if you take vector in the same direction, so we divide by 13, and in the same direction, but 13 times shorter, we'll get unit vector in that direction. Make sense? Yes.
If I'm going left or down, it would be negative I and negative j.
If we have, let's say, vector, let's say this vector, if this point will be minus 5, this is minus 3, this vector will be negative 3i
Minus 5j.
minus 5j.
Okay.
Yes, can be negative, it's represent direction.
Yeah.
Now let me double check what else I wanted to explain today. And we will little bit introduce, I will introduce the vectors in the 3 dimensions.
3 dimensions.
In 3 dimensions, we have x, y, then we add z-axis, which is perpendicular to
That's cool.
x and y. So we can draw it the next way.
Does the complex plane also have a 3-dimensional
No.
version?
Complex numbers 2-dimensional.
Right.
So we have x-axis, y-axis, and we have z-axis. And we already know that in x direction we have unit vector I, in y direction we have unit vector j, and in z direction unit vector called
Is it
k.
always the same? These
I, j, and k always I, x, j, y, k, z. So what will be the length of the vector 2i plus 5j minus minus root 3k. What will be the length of this vector?
4. Is
Length.
it?
We need to do
Four root
square
two,
root
four
of
root
2
two.
squared plus 5 squared plus negative root 3 squared. No.
No, you square root.
No, sorry, not root squared. Plus minus 3.
What?
Minus 3. Minus. So plus 3 squared. What it will be equal?
It's a very weird number, this is.
4 plus 25 is 29, 29 plus 20 plus
Plus
9 is
Why would you
38,
do that?
38.
Why is that? Like, why would you?
29. We have 29 plus that's 38, so root 38. Length of this vector is root
20,
38.
how'd you get to 4?
It was, root 3, it was 4 root 2.
So we can find length of the vector in 3
But
dimensions.
how do you plot this vector on the plane?
No, we cannot really show on the plane
Okay.
on 2 dimensions.
Yeah.
It will be pretty hard to draw.
Yeah, okay.
Especially, no, if it will be z, if I will make plus 3k, you still can do like 2,
Yeah.
x coordinate 2, y coordinate 5, and then we have 3 up. So that will be something like this. But it's not in that plane.
Yeah.
It's like 3 dimensional and it's 6 like this. Yeah.
Damn.
But this year it's just pretty much just only introduction. You will do much more. This in unit 1, 2 it's supposed only in 2 dimensions. But I think to expose you this year, when next year we'll be dealing with the 3D.
So your grass said that we should do 3D?
Just have a little bit of introduction.
Yeah.
Now, example with the components. Let's say example on the page booklet, page 15, and question example 12. Example 12. So we have two vectors. Vector A equal xi
The hell is S?
minus 4j
Where can you see S, Joseph?
Huh?
Where can you see S?
and vector B
Ask what the hell is S?
B equal 3i plus 5j. Question is if the length of the vector A is 6, find x if the length of the vector A is 6.
Easy.
So we have x squared plus 4 squared equal
2 root 5.
Plus minus 2
equal
5
36.
Is this question?
Ah.
It is
Okay.
page 15, question 12.
Say yeah, minus 1.
So we will get x squared equals 20. So x equal
Plus minus 2.
plus minus 2 root
So you
Fine.
check that?
plus minus 2 root 5. So there could be 2 solutions.
Yeah, did you hear that second? 2 solutions.
Now,
This is just confusing me
How
because
does
it's basically the
77
same as.
Pardon?
It
How
feels
does
the same
77
as
treat?
complex
As in
numbers.
versus market shooting.
Because you add the real and imaginary. That's what it's kind of like.
it's me. I understand why he asked about the S.
Yes.
It's
That's
missing
what
in
you
the
mean.
equation. It's missing in the equation.
Ah.
I should have
Did
chosen
you
this
see that S
one.
again?
Does he mean B?
Huh?
Does he mean B maybe to the vector B?
No, really?
No,
There's A and B and A's already
no,
spoken.
no, no.
You
It's
think
something.
it's
It's
What the fuck is
something.
this?
Is this Russ's book?
Yeah.
Guys, it's on video. It's on video.
Now turn page over. Page 16, example 13.
Parts.
And we'll do part B. We have vector A. We have vector A equal 4i minus 5j minus 5j. We have vector B
Question is.
Oh my God.
13b. A equal 4i minus 5, B equal minus 7i plus 3j.
BJ.
And we have MA plus NB equal 8i plus 13j. What equal, what M equal, what N equal?
Oh, it's in the wrong way.
Simultaneous, right?
You will get simultaneous equation. So we will have MA plus NB means 4M, 4MI,
N equals to 4.
mo-
4 actually.
4MI minus 5MJ plus minus 7 minus 7NI and plus 3NJ.
Yeah.
And that's equal 8i plus 13j. Two vectors
There's no
are
need
equal
to
if
solve
they're
this.
I
Add the i's up and make
So
i's
you
equal
have
and j's equal.
4m minus 7n
They just copy complex numbers.
It's literally
equals-
copying, it's literally complex
Copy
numbers.
equals 8,
Copy.
and we have minus 5m
It is simultaneous though.
Oh, it is all.
plus 3n
No.
equals 13. 4m, because I components 4m minus 7n has to be equal the I component of this vector equals 8, and j components minus 5m plus 3n has to be equal 13. So we just need to solve those simultaneous equations. I propose multiply both equations, this equation multiply by 5, this multiplied by 4 to do elimination. We have 20m minus 35 n equals 40.
N equals negative 4.
We have minus 20m
Negative 4 answer.
plus
It's negative.
12n
N equals negative 4.
equal 52. We add them to eliminate m. We get 12 minus 35 minus 12, 20, negative 23. n equal 92.
N equals negative 4.
So n equals negative 4.
Yeah.
And then we substitute
N
this
equals negative
into let's say here, we get 4m plus 28 equals 8. Obviously m equals negative 5.
Ow.
So that's how we're dealing with the component of the vectors in x and y
That's the chill
direction.
bit.
Like, subscribe and donate to help fight terrorist countries and organizations like Russia, Iran, Hezbollah, Hamas, etc. Support
Hezbollah.
Ukraine and Israel.